Let me explain something that is typically a fairly tricky thing, and that's why I want to kind of hit it a second time. We use a little fact that the sine of an angle will give us the exact same answer as the sine of 180 minus that angle. Now that is fairly obscure and not very clear to most students. And so what I'm going to do is try and show you why that is. So let's just start with the sine of an angle. Let's make this our angle, theta. Now the sine of that angle would represent the opposite side over the hypotenuse. Now you and I know that whatever that angle is, that opposite to hypotenuse is a fixed value. Now why would the sine of 180 minus theta be the same? Now if I go down to this other area here, I'm going to make theta again. Let me make angle theta again over here. Now why did I make it there? Well, if I'm trying to show you what 180 minus theta looks like, I take the straight angle of 180 and I subtract that theta. And that angle is 180 minus theta, isn't it? Now, why do we get the same answers whether we are looking at this guy here, this angle here, and this opposite to hypotenuse? Why would we get the same answer if we're looking at this angle of 180 minus theta when I compare the opposite to this hypotenuse? And the answer is just simply this, that 180 minus theta generates theta over here, and we get the exact same opposite side height, and we get the exact same hypotenuse. These values, opposite is positive, hypotenuse is positive, opposite is positive in this quadrant, hypotenuse is positive. So in this moment in time, the sine of the angle of theta will always equal the sine of 180 minus theta. So when we look at an obtuse angle and we want to find the height here, and we want to use this angle, well, because we're using the sine of the angles, whether we do the sine of the angle in the interior or the sine of 180 minus that, this tells us we would get the same answer. So that's why they are exactly the same.